to talk about slope in polar. So this is an APBC topic, right? So this is APBC because you don't see polar in calculus until you get to APBC calc. So let's talk about slope first. So the first thing we need to know about slope is that slope forever and always is change in y over change in x, right? So sometimes you'll see that in calculus as a dy dx. Sometimes you'll see it in old school algebra as rise over run. Sometimes you're physically counting on a graph, like how much did y change, like what is the rise over how much did the run change, or how much is the run, what is the change in x. So the reason that's relevant is that when we're in polar, we still want dy dx, right? So we've seen this in parametric before. When we do this in polar, the way we get dy dx is we find dy d theta over dx d theta, right? Or if you prefer to think about it as y prime of theta over x prime of theta, that's the same thing. It's fine. But essentially, if we do this, right, if we do dy d theta over dx d theta, when we simplify this fraction, the d thetas would cancel, and I would end up with dy over dx. So now that doesn't sound awful, except we saw it in parametric, it wasn't terrible, but what makes it a little bit harder in polar is if we go back to think about the relationships that we have between x and y and r. We learned in a previous video about polar and rectangular coordinates that we can write x as r cosine of theta, right? And we can write y as r sine of theta, right? Now that's fine, but if your r is also a function of theta, right? So in APBC calc problems, right? Our r, right? So in APBC calc problems, our r is usually some function of theta. It's not just a radius of 5. It's not this isn't a circle that always has the same radius. It's usually r is some function of theta. So if you realize that, then what you're going to realize is that in order to find dx d theta, right, you're going to have r, which is some function of theta times cosine theta, and the same thing is going to be true of your y, which is that function of theta, right, times the sine of theta. You're going to have a product rule when you want to find your x prime of theta. So if you try to find x prime of theta, right, so if I want to find x prime of theta, I'm going to have a product rule with a u and a v. So I'm going to get u, which is f of theta, dv, derivative of cosine is negative sine, right, plus v, which is cosine theta, du, which is f prime of theta, right? And if I wanted to find my y prime of theta, right, my dy d theta, right, if I want to find this guy, I'm low on space, so I'm just going to write and my y prime of theta by the same rule. I've got a u and a v, would be u, right, f of theta. dv is going to be cosine theta. Plus v, which would be sine of theta, du, which will be an f prime of theta. So what that means is that you'll see a lot of textbooks actually give you this formula that dy dx, right, for a polar curve is this blue thing, y prime of theta, right, over this red thing, x prime of theta, and they'll actually have you memorize that it's this. Now, I don't personally have this memorized. I've never seen a reason to have this memorized, and the reason I don't have it memorized is because it's essentially just the product rule, and I just don't think it's worth it. You're welcome to disagree with me, and that's just fine. This is definitely a formula that you'll find in some textbooks, but in 20-some years of doing calculus, I've never felt the need to have it memorized, and I'm not going to change my plan now. So it's a negative f of theta times sine of theta plus an f prime of theta times a cosine theta. So again, f prime varies, but this is the formula that a lot of textbooks are going to give you to find the slope of a line tangent to a polar curve. Good times. And again, that's a negative, not just a really aggressive f. So that was a negative. So use that formula if you want, or you can do what we're going to do in some of the examples, which is I don't have this memorized. I'm just going to do the product rule and go from there.